Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I just want to explain activity 1 of graphs 9, which is bringing us towards the end of the topic, whereby we have been dealing with gradients, calculating gradients, and everything to do with gradient, maxima and minima points. Now, in this activity 1, we are told that the Dimox paint factory wants to store 50 meters cubed of paint in a closed cylindrical tank. And to reduce cost, it wants to use the minimum possible surface area, including the top and the bottom. Now, if the total surface area of the tank is A meters squared and the radius is R meters, show that the height H meters of the tank is given by H is equals to 50 over pi R squared. There are some fundamental information that we should be having both in the calculations of the surface area of a cylinder and in the calculations of the volume of a cylinder. First of all, the volume of a cylinder, let's call it V, is always equals to the base area, which is pi R squared times the height. That is always the formula to calculate the volume of a cylinder. And in this case, we are told that the volume is 50 meters cubed. So the volume here, in other words, V is 50 meters cubed. The surface area of a closed cylinder is given by the area of the bottom, which is a circular in shape, pi R squared, plus the area of the top, which is also circular in shape, which is pi R squared, plus the area of the curved surface, which is 2 pi R H. And I want to just demonstrate it here. So if you open up a cylinder, you will get a top which is circular. The curved surface will give you something like rectangular, and the bottom surface will give you again circular, something circular like that. So this is the R, and of course this is the height. The moment you have the top and the bottom, we have no issue because the formula is just pi R squared and there are 2, so we are going to have 2 pi R squared. But I want us to think about the distance from here to here, which is the same distance from here all around the circle to the same point. Because if you want to fold back the cylinder, you'll have to get this length and this length, go around this circle and meet somewhere here. So this length is equivalent to the circumference of that circle. So in this case, and we know the circumference of the circle is 2 pi R. And that is how now the area of this rectangular shape is 2 pi R H. So if you would want now to consolidate the surface area of the cylinder, is this plus this, which is 2 pi R squared plus 2 pi R H. That is it. And of course, let us now go to the questions, because the first question is, if the total surface area is A and the radius is R, show that the height of the tank is given by 50 over pi R squared. And of course, you can see it here. If the volume is 50, we can start from there, because pi R squared H is equals to 50. Making H the subject of the formula, we divide both sides by pi R squared by pi R squared, divide by pi R squared by pi R squared, and you can already see that H is equals to 50 over pi R squared. and that is shown as per the requirement of Part A. Part B, we are supposed to use this to show that area is 2 pi r plus 100 over r. And of course, it means that the surface area now, that is part A, part B, we are talking about the surface area, which is basically 2 pi r squared plus 2 pi r h, and h is that which is 50 over pi r squared. Of course, it goes without saying, 2 times 50 is 100. Pi will cancel with pi. 1 r will cancel with 1 r here. And we are going to remain with r at the denominator. So in this case, we can already say that area is equals to 2 pi r squared plus 100 over r. And that is just like it. So we have been able to answer part A of the question and part B of the question. Now we have to try to answer part C. Show that dAdr is equals to 4 pi r minus 100 over r squared. In other words, the derivative of A with respect to r is just that. And we have to start with what r is, what A is. Of course, we know A is equals to 2 pi r squared plus 100 r raised to power negative 1. The reason why we have raised r to the numerator position is because we have just realized we are going to differentiate that function, and we are going to have dA dr, the differential of area with respect to the radius is going to be 2 times 2, which is 4 pi r raised to power 1, because we reduce it by 1, minus 100 r raised to power minus 2, because we are reducing everything, the index by 1. So in other words, this is already 4 pi r minus 100 over r squared. Again, when r takes the denominator position, then the index changes. The index changes the sign, and that is just like it. So in other words, we are simply saying that dA dr is 4 pi r minus 100 over r squared. That's where we are, and part B is solved. What about part C? Part C, as far as we are concerned, we are told that solve dA dr is equals to 0 to find the dimensions of the tank that will produce the minimum surface area of the tank, and state this area. Now, we have always known that at the maximum or minimum point, the differential, the first differential, should be equals to 0. So we are simply saying dA dr is equals to 0. And this means 4 pi r minus 100 over r squared is the one which is equals to 0, because it is dA dr. In other words, we are saying 4 pi r is equals to 100 over r. And if we can cross multiply, this one already takes us to 4 pi r. This is pi r. This is r squared. This is 4 pi r cubed. R power 1 times r power 2 is r cubed, is equals to 100. But we want to make r the subject of the formula, because without r, then we cannot get the surface area. In other words, we can see if you divided both sides by 4 pi by 4 pi, we are simply saying that r cubed is equals to 100 over 4 is equals to 25 over pi. And in this case, r is equals to the cube root of 25 over pi rather. 25 over pi. So let us see, what is 25 divided by pi? That is 7.95, and we need to get the cube root of that. So the cube root of answer, we get 1.9964. So r is the cube root of this, which is basically to the nearest whole number 2. Let's talk about 2 meters. That is the cube root. Because our answer is 1.9964, to 1 decimal place or even to 2 decimal place, we still get 2 meters. Now with the value of r, we can be able to calculate. The surface area, and this surface area, as we all know, is actually equals to, if we may write it again here, area is equals to 2 pi r squared plus, if you consider this one, 100 over r. And that is just what we are having. But r is 2. This is exactly what we have as our area. We have picked it from there. And therefore, area now becomes 2 pi 2 squared plus 100 over r, which is 2. And I just want to talk about this, which is 2 squared, which is 4, times 2, which is 8, times pi, which is 25.13. This is, at this point, this is 25.13, plus, you can see 100 over 2 is 50. So 25.13 plus 50 is easily 75.13. So the area in general is equals to 25.13 plus 50, which is 75.13 meters squared. And that is how we have been able to explain that activity 1. Please follow, and of course, let us meet in the next video. It's a long question, very good question. Just follow it and let us work together.